have received the recordings of earlier two lectures? I
Yes,
have
sir.
shared it on the classroom, in the classroom. Scan.
Yes, sir.
Mail किया ना scan. Oh, okay, fine. So we were discussing about this moment of force, and we have seen that whatever discussion earlier we did, that was related to the forces which are of this manner, horizontal, vertical, or inclined. Now, these forces necessarily will develop translatory type of motion. Translatory. Translatory in the sense moving in one particular line, isn't it? So if you say that this is a rigid body and this rigid body is being applied with this force, whatever force I am applying. So with the help of this force, this body is moving in one line, isn't it? So all these are your translatory type of motions. Now, in case of moment, as I had discussed, I have also shown you the example that if I clamp this rigid body, I'm treating this as a rigid body because even after the application of force, the deformation cannot be seen. Okay, deformation of this rigid body cannot be seen through the naked eye. So that's why I'm terming this to be a rigid body. So let me consider this to be rigid body. And if I am applying certain type of force like this, 1 minute. Hello. Um, right. So, yeah, I was discussing about this thing. And if I apply this force in this manner, so what this force is doing to this rigid body, it is trying to rotate it about this point, isn't it? So let me draw this situation in this manner. So let me consider this to be a rigid body. Okay, I am holding this rigid body at this point. Let me call this point to be point O, origin, whatever you can say. Okay, then I am applying certain amount of force. Now, this force is actually a translatory type of force, in the sense, whatever motion this will cause, it will be in the straight line or whatever line of action of this force carries, right? So, let me call this as capital F. But as we have discussed, by virtue of this force, in this case also, if you have noticed, the direction of force is downwards, and therefore I have shown the arrow in the downward direction, correct? So what happens, by the virtue of this force, this point, it is rotating about this point in this manner. Okay, so the position, final position of this rigid body may be something of this sort. Okay, so it has rotated by an amount of, let's say, theta. Correct. So this process or this action of the force is known as moment, because it is causing a rotation about this point O. So when we define moment, it is nothing but that force uh, which is responsible for causing a rotation about certain point. So whenever we talk in terms of a moment force, what we say, there are few other parameters which are associated to it. So let us try to understand what are those other parameters in order to define a moment. Is there any problem?
No, sir.
Yes.
No, sir.
Uh, should I continue?
Yes, sir.
Okay, okay, fine.
Yes, sir.
Okay, right. So let us discuss about those parameters associated to define moment force. So fine. I will speak in terms of this example only. And over here, let me say that a force is acting on a rigid body at this point. So you can say this is point of application of force. This is point of application of force or line of action of the force. Point of application of line of action of the force on the rigid body. Right? Then this point O, this is known as moment center. This is known as moment center. CTRE. Okay. This is known as moment center. Right? There is one more term which will be required for us in order to define moment mathematically. So for that, I should know this distance, small d. And if you can see from this figure, this small distance is actually acting it is acting in the fashion of perpendicular distance. Okay, so small d, this is a perpendicular distance between the moment center and the point of application of the force. Okay, so this necessarily should be perpendicular distance. So what I can say, d is the perpendicular, let me write it, perpendicular distance between moment center and point of application of force. Right? So this is a prerequisite in order to define moment mathematically. So what is the prerequisite or what is the requirement? That whatever distance between the moment center and the point of application of the force, this should be perpendicular, right? So if I want to define now moment which is caused because of this force F, this is defined mathematically in this manner. Moment due to force F about certain point, which is known as the moment center O. So how is the representation of moment? Moment, capital M. By what force it is being caused? That is capital F. And it is rotating about which point? That is your moment center. This is the complete representation. And now if I want to express it mathematically, then that equation becomes force into the perpendicular distance. Got it? So this is how mathematically the moment equation can be derived, or it can be expressed, right? So how do you represent this moment force? It is capital M, that is moment, which is developed because of certain force, external force, capital F, about certain point, which we call it as moment center, suffix moment center, is equal to force into the perpendicular distance. So is this correct? Have you understood this thing? Okay?
Yes,
Understood? So how to define moment? In simple words, it is nothing but the line of action of the force, and it is nothing but the product of line of action of the force and the perpendicular distance, which is starting from the moment center to the point of application of the force, right? That is nothing but this d. Okay. So whatever I have told, that was with respect to the xy axis. Not necessarily that you will find everything in this two-dimensional axis system. You can expect something in space also, right? So in space, if there is certain rigid body like this, three-dimensional, okay, and let's say that a force is getting applied in this manner, and if I wish to find out moment about this certain point, okay, so what I will do, in order to find out the moment about this point, let me call this point to be point O. By the virtue of this force, let's say capital P, let's say for example, right? So what will be the definition? According to the definition, it is nothing but the product of force, line of action of the force, which is applicable from the moment center to the line of application of the force by this term small d, which is perpendicular distance, right? So moment about because of force P about point O, or you can also call this as axis of rotation. About this point O, or you can even say axis, about this axis, it is nothing but P into small d, right? So this is the moment center, or if you want to represent it with respect to the axis, you can even write this equation. Okay, so this is how the moment equations, a moment equation rather, it is expressed. Right? Have you understood this thing? Okay. हाँ, हाँ, ठीक. Link से Sorry, students. Let us again start. Fine. So we have defined moment force. Now you must have understood that moment is another type of force again. The only difference is instead of causing a translatory type of motion, it is causing rotatory motion. So since moment is a force, that means it should have some unit associated to it, isn't it? Not only unit, but it should also be associated with direction, isn't it? So, what according to you may be the unit for moment? For that, let us revise the formula. What it says, moment about any point O due to force F is given by force into the perpendicular distance. Okay. What is the unit for force? Let's say Newton, and distance, it is meter. Okay. So the unit for moment will be Newton meter or kilonewton meter or Newton mm, kilonewton mm, so on. Understood? So moment will have this unit of Newton meter or kilonewton meter, whatever it is, because it is the product of force and the perpendicular distance, right? Now, this is with respect to the units. Since it is a force, it will have direction. So now let us try to discuss what will be the dimensions associated with moment force. So again, in order to understand that, let me consider this example one more time. A rigid body, this is moment center, and force acting in the downward direction. Okay. Because of this, capital F, about this point O, how does this rotate? What will be the direction of rotation? In this manner, do you agree, all of you?
Yes, sir.
So, this is a clockwise type of rotation, isn't it? Clockwise. Okay. We will decide that whenever we get a moment which will create clockwise type of rotation, that moment we will term it as positive moment. So this is the direction which we will be following. That is, if the moment is creating a clockwise type of rotation, then we will term it as positive moment. Got it? And in reverse of this, if the moment caused is in the anti-clockwise direction, we will term it as negative. तो ये सिचुएशन कैसे हो सकती है, कब होगी? So let me again one more time explain you with this example. Instead of the force which was acting in the from the upward direction, let me say that if the force is acting like this, okay, so how it will rotate? How it is rotating like this? That means it is rotating in the anti-clockwise direction. So let me represent that case. This is again that rigid body, same rigid body. Okay, this is the moment center, and this is the point of application of force capital F. By the virtue of this force, how this rigid body will move? Move in the sense rotate. This is going to rotate in the anti-clockwise direction. So this direction is anti-clockwise. And whenever anti-clockwise moment is achieved, In that case, we say negative moment is obtained. So these are the sign conventions which we need to follow whenever we find out moment of a force. Okay? Have you understood these sign conventions?
Yes, sir.
Yes, sir.
So if you have understood this thing, can you please let me know if the rigid body is not horizontal, let me say it is vertical. And let me say that this point is moment center, and I am applying the force capital P over here. The perpendicular distance between the moment center and the point of application of the force, let's say small d. This is the perpendicular distance. Okay. What will be the moment equation in this case? How I may represent it? Moment about point O, which is moment center, because of force P. What will be the value?
So P into D.
P into D, correct? What will be the direction associated to it?
Anti-clockwise.
Clockwise.
Clockwise.
Yes. For that, let me draw this. How is this rotating?
Anti-clockwise.
Anti-clockwise, right? So as per our discussion, earlier discussion, if it is anti-clockwise moment, it should be negative. So this is equal to minus P into D, correct? Similarly, if it is in this manner, point of application of the force, capital F, D is the perpendicular distance between application of the force and moment center. So the representation shall be F into D. Now the rotation is clockwise, therefore this is positive. Got it? So have you understood the sign conventions?
Yes, sir.
Right. Now you will find the application of calculation of the moment in your structural analysis course that you are going to study in the next semester. Over there you will find the maximum application of this moment equation, and it will be used every now and then. So if you practice the numerical which we will be solving in engineering mechanics course thoroughly, then you will find that uh, in essay, that is structural analysis course, the application is very simple there. Okay, so let us try to solve few numerical based on which you will get some complete idea related to certain numerical. Okay, let us start with very simple numerical. Right. So these are the yes. This is point B, and the distance from this origin is 4 meter, and there is one force which is mentioned over here. The distance of this point of application of force from origin is 3 meter. This is given, and there is one force whose magnitude is 500 Newton. This is capital F, 500 Newton. ये दिया हुआ है. in this numerical, uh, point B is mentioned, and what you are supposed to do is you are supposed to identify the moment which will be caused by this force F about point B. This is the problem statement. So what exactly you need to find out is moment about point B due to capital F. How to proceed? Now you can see point B is at a distance of 4 मीटर from this origin. अभी तक जो मैंने डिस्कस किया उसमें आपने देखा होगा कि the application point of application and the moment center, they are, you can say they are on one line, or it is lying in one plane. However, over here, what do you see? That this point B is far away from the application of the force F. So in such case, what we can do is we can make use of this equation of moment about point B due to F. What is the equation? What will be the equation?
F into D.
Force into the perpendicular distance, and this perpendicular distance should be necessarily from the point of application of the force and the moment center. So in our case, the moment center is point B, isn't it? So what we will do, there is one advantage of principle of transmissibility. What it says, what is the principle of transmissibility? That the effect of the force which is acting at one point, that will be constant along its line of action of the force, right? So what I will do, I will extend this line of action of force F in this manner, isn't it? I will extend, and you will see that at every point on this line, the magnitude of force F shall be same, that is 500 Newton, and this liberty is only based on the principle of transmissibility. Okay, with this, now the question will be of D. Okay. What I will do, D necessarily is a perpendicular distance, as I have told you. In order to find out moment, this D should be a perpendicular distance. Simply I will do what I will do, I will plot this perpendicular distance, okay, and I will call it as small d. Looking at the geometry, what should be the value of small d?
Three meter.
3 meter. बराबर है? Because I have extended this line of action of force, which is parallel to this x-axis. This is x-axis, and I have dropped a perpendicular from this point B up to this point, which is parallel to the y-axis. So from here, since this distance is 3 meter, D will be 3 meter. Understood? So if this D is 3 meter, F we know, can we not find out moment about point B due to F? It is very simple. Substitute the values. F is 500, D is 3. Now this was related to the magnitude. This is associated with direction also, because moment is again a force. In which direction do you think this will rotate about point B? What will be the direction? Whether it will be plus or minus, clockwise or anti-clockwise?
Sir, minus.
Yes, yes.
Clock.
Sir,
How it
minus.
will rotate about point B? This is going to rotate,
Sir, anti-clockwise.
yes, like this. It will be anti-clockwise. So since it is anti-clockwise, minus sign will be involved. Minus 1500 Newton meter. This is very, very important. Huh? Always mention the units. समझ गए? Simple. One more simple numerical associated to this. Okay. This is point A. This is point A. And one force is given, which is acting vertically downward. Vertical force, yeah. This is vertical force. And the distance of this from this point O is 5 meters. And this point from O to A, this is 4 meters. Magnitude of this force F is 400 Newton. You are supposed to identify the moment about point A due to F. Similar type of numerical, except the nature is somewhat different. Right? So, firstly, what I will do, I will write down the moment equation. Moment about the point A due to force F. What it will be? F into D.
So 1600 Newton meter.
Yes. So D. I need to find out D. Okay. So as you know, earlier what we did for such cases where the point of application is away, we will extend the line of action of the force. And in order to find out this D, I will drop a perpendicular. What according to you should be this small d?
So 5 meter.
Exactly, it will be 5 meters. Okay. Substitute the value 400.
2000 Newton meter.
2000. But what will be the nature of this? Clockwise, anti-clockwise?
So clockwise.
Exactly. This is clockwise. So this is plus or 2000 Newton meter. Again, I am repeating. Please be consistent while writing the unit. Very simple. Okay. Now, we have discussed about vertical and horizontal forces. Let us now try to see what will be the situation if we consider some inclined force. So in such situation, this is X, this is Y. On this axis system, this force F, this is inclined. Magnitude is 600 Newton, and this inclination is given as 30 degree. 30. This distance from O to this point, it is given as 4 meters. Okay. You are supposed to identify this value, moment about point O due to F. So as per the definition, what it should be? F into perpendicular distance. Now the question is how to identify this perpendicular distance in this case. क्या करना होगा?
F sin theta लेना पड़ेगा.
That I will be discussing later on. I mean the components, whatever you have told, that is correct. But there is another way. If I take talk in terms of this equation only, time being I am not considering the components. If I want to avoid the component part, what I will do, I will extend the line of action of this force like this. Isn't it? And from here, in order to calculate the perpendicular distance, I will drop a perpendicular from this point O. Okay? And I will identify this small distance d. That can be easily identified because we know this side, this is 4 meter, and I know this 30-degree angle. From here, again you will get some value of d in terms of sine or cos theta, that is for sure. But this is one of the ways before resolving this into components. So what I have done, I have extended the line of action of this force and then dropped a perpendicular from this moment center. This is known as moment center, and this d, I have dropped a perpendicular. One thing I forgot to tell you, that this d is also known as moment arm, or it is also known as lever arm. Moment arm or lever arm. Okay? So this is a moment arm. What we do in order to calculate moment arm, we drop a perpendicular. Okay? So fine. So what will be the value of d if I do all these things? What should be the value of d? Can you please let me know from the geometry? Right. Yes, can anyone tell what will be the moment arm value? Small d. Will it be 4 sine 30? Am I right?
Yes,
Please
sir.
check.
Yes, sir.
Yes? Fine. So what you do, you substitute that. Substitute that value in this equation. 600 into 4 sine 30. And what is the remaining thing? Decide upon the direction. So in which direction do you think this force will create a rotation? Whether it will be in anti-clockwise or clockwise direction. Situation is like
For
this.
anti-clockwise.
Exactly. It is going to rotate in an anti-clockwise direction. So this is negative. So whatever
Minus
may be
1200 Newton meter.
yes, whatever may be the value, you write down. I think it is how much? Minus 1200.
Yes, sir.
Minus 1200 Newton meter. That is very important. Okay? So this is how. This is one of the way which can be followed whenever there is an inclined force. But you will see that a force system will consist of many forces which are acting on a rigid body. So this is an isolated problem, you can say, wherein only one force is getting applied. In such cases where more number of forces are applied on the rigid body and those are inclined, there is one more method that I will be explaining you in the next class. Right? That is known as Varignon's principle. With the help of that Varignon's principle, how to find out the moment values, that we will see. So I will stop over here. I hope you have understood this thing.
Yes, sir.
Okay.
Yes, sir.
Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes.